Hello, everybody. Welcome to Monday. I hope you had a wonderful weekend. So we're going to continue with functions, modeling, and predicting change. And we will go to our next slide here, which is a picture of the linear function or the linear model, which is y equals mx plus b. And last week we learned about the m letter in this linear function, and m is the slope or the rate of change. And today we will start learning about the y-intercept, which is the b value, and that is our starting amount or the initial value. Okay, so when you look at this linear function here, you see y equals 2x plus 1. So in this particular function, your slope or rate of change is 2, and your y-intercept or the starting amount or initial value would be 1. And if we go here to this Desmos graph real quick, you can see where I've graphed this line. And right here at the point 0, 1, this is where your line crosses the y-axis. So that's why it's referred to as the y-intercept. So just like you hear in football about a quarterback throwing an interception, that's because another player crosses the plane of the ball. It's very similar to the y-intercept. It's where the line crosses your y-axis. All right, so if we go to our guided notes for today, and we'll start right up here with the definition of the y-intercept. And what it is it is the starting amount, and it's also, well, actually, let's start it this way. It is the initial value or starting amount. Okay, so that's what your y-intercept is. It's the initial value or the starting amount, and it is where the graph crosses the y-axis. Okay, so this is something that every function we learn is going to have. Every function is going to have a y-intercept, a point where it crosses the y-axis. All right, so what we want to do here for this first part about how a y-intercept can be represented in a graph is we want to highlight, as it says here, the y-axis. So if I come down here to both of these graphs and just highlight where my y-axis is, you're going to notice that there's a point where that line crosses the y-axis. Here the point is 0, 1, and here it is the origin 0, 0. Okay, so we're looking for the point where the line crosses the y-axis. So again, here it would be 0, 1, and then here it's the origin 0, 0. All right, so if you're looking at an equation now, if you're trying to find the y-intercept from an equation, the equation must be in what we call slope-intercept form. So in this particular equation, m is your slope, b is your y-intercept. All right, this is slope-intercept form, and we're going to learn two other forms of the linear function probably next week and the week after. So the y-intercept is the number that is being added or subtracted, okay? So in this particular equation, y equals 4/3 x minus 12. All right, the number that is being added or subtracted is the 12. Now, it's very important that whatever sign is in front of your y-intercept, that you keep that sign, because that's going to tell you which side of the y-axis you're on, if you're on the positive side or the negative side. All right, so here again, if you look at the next one, we have y equals negative 3x minus 2. All right, again, 0, negative 2, because you keep the sign that is in front of the number. So here I've got y equals 15x plus 7. So plus 7, or just 7 by itself, would be the answer here. And then, of course, you've got y equals a negative 0.1x. Now, when you see something like this where there is not a y-intercept in plus or minus form, that means it is your origin 0, 0. Okay, so for this particular D, 0, 0 is going to be the point where that line crosses your y-axis. All right, now if your y-intercept is represented from a table, all right, what I want you to do is number 2, cross out, because we're going to do another lesson that addresses that specifically, and table B, cross out. Okay, we're going to do those in a separate lesson. So just look at the top where it says from a table. Look for where the y-intercept in the table, where your x value is 0 and the number that corresponds to it. So if you look here at A, right here is your y-intercept, because your x value is 0 and the number that corresponds to it is 2. And that should make sense to you because it's an ordered pair and you're not going either left or right, you're just going up or down. Okay, so that's all we're going to do with the table for today. Now, if you look at a word problem, okay, it says here to look for the, and what we're going to put up here is the word starting amount. Okay, so when you're looking for your starting amount, you're looking for what amount is the scenario is starting with. So for example, in A, it says Jack has 5 toy trains. So has is the amount that he is starting with. He has 5. Okay, and then it says he plans to buy 2 each month. So the words right here, each and month, indicate change. Those are key words that indicate change. So if we were going to write this as a linear function, we would write y equals, so what's changing each month? 2. So he's getting 2 per month, so 2x, and he starts with 5 because he has 5 toy trains. So y equals 2x plus 5. All right, on our next scenario, it says the initial fee. So there again, there's that key word, initial. We set up here initial value or starting amount. So initial fee to have a website set up using a server is $48. It costs $44 per month. So again, those words per month indicate change, something that's changing each month. So this would be y equals 44x, because that's where the change is occurring, plus 48. And then our last one here says an online camera store charges $1.49 for every. Okay, so there again, for and every indicate change. For every 8x10 picture that you order. And then it says the shipping cost is $5.50. So again, y equals, how much are we changing by? $1.49 per picture. Okay, and the shipping cost is $5.50 because that's being added to each one, and it's also the constant in this particular problem. Okay, so it's your starting amount, and it can also be your constant amount, as you see down here. All right, so for our last example of how the y-intercept can be modeled, we could look at from 2 points. So what you're going to look for here is where we have 0 and a number. So this is not really any different than looking at it from a table because you're still looking for an ordered pair. So in example A, our y-intercept is going to be 0, 5. 0 and the number. In example B, I have 2 ordered pairs. 0, negative 6 is going to be the y-intercept. 0 and a number. In example C, I have 0, 7 and negative 5, 11. Same thing. 0 and a number. This is my y-intercept. So those are the different ways that the y-intercept, which is also the initial value or starting amount, can be modeled. So what you're going to do today is we have slope-intercept word problems. And this is really just more of what we just got done doing here in this column right here. So you're going to read each problem and write a linear function that models it. So for example, it says write an equation in slope-intercept form that models each scenario. The first one is done for you. And never mind this part here. This is from a different assignment. So don't worry about the salary analysis notes. Just submit through Google Classroom when complete. I thought I fixed that. Sorry. Don't worry about salary analysis notes. All right. So example, Osland has a gym membership plan that charges a $50 membership fee and $10 per visit. So y equals 10x plus 50. There's an upfront fee. That's your starting amount. And then you have $10 per visit. That's your 10x. Okay? So there's just 10 of them for you to do. And also do the calculating slope assignment as well. Like I said, ignore this piece right here about the salary analysis notes. We're going to do salary analysis in a different order. All right, everybody. So that's all for today. Have a great day, and I'll have another lesson for you tomorrow.